Demystifying Containerization with Docker. Section 1. Introduction to Containerization and Docker. In today's fast-paced world of software development, agility and scalability are paramount. Traditional methods of deploying applications often involve complex dependencies, compatibility issues, and lengthy setup times. This is where containerization comes in. Containerization is a method of virtualization that allows applications to run in isolated environments called containers. Each container contains everything needed to run the application, including code, runtime, libraries, and dependencies, unlike traditional virtual machines, which require a separate operating system. For each application, containers share the host operating system kernel, making them lightweight and efficient. Docker, the leading platform for containerization, provides tools and services for building, managing, and orchestrating containers at scale. With Docker, developers can create Docker files to define the configuration of their containers, use Docker Compose to manage multi-container applications, and deploy containers to any environment using Docker Swarm or Kubernetes. Section 2. Understanding the benefits of Docker. Docker offers numerous benefits for developers, operations teams, and organizations as a whole. By decoupling applications from the underlying infrastructure, Docker enables faster development cycles, improved consistency across environments, and simplified deployment workflows. Docker promotes a microservices architecture, enabling teams to build modular, composable applications that can be independently deployed and scaled. Additionally, Docker provides resource isolation, ensuring that containers run reliably and consistently across different environments. This level of consistency reduces the risk of configuration drift and minimizes the chances of deployment failures. Docker also facilitates collaboration among team members by providing a standardized way to package and share applications and their dependencies. Moreover, Docker's lightweight nature and efficient resource utilization make it an ideal choice for building and deploying applications in cloud-native environments. Section 3. Use cases for Docker. Docker is used across a wide range of industries and use cases, from web development and DevOps automation to data science and IoT deployments. In the e-commerce industry, Docker enables organizations to rapidly deploy and scale web applications, handle spikes in traffic during peak shopping seasons, and streamline the deployment of new features and updates. In healthcare, Docker facilitates the development and deployment of HIPAA-compliant applications, improves the reproducibility of research experiments, and accelerates the delivery of healthcare services through telemedicine and remote patient monitoring solutions. In finance, Docker helps organizations build secure and scalable banking and trading platforms, optimize risk management and compliance processes, and modernize legacy systems through containerization and microservices adoption. These are just a few examples of how Docker is transforming industries and enabling organizations to innovate faster, deliver better products and services, and stay ahead of the competition. Section 4. Getting started with Docker. Getting started with Docker is easy and straightforward. Begin by installing Docker Desktop on your development machine, which provides a user-friendly interface for managing containers and images. Once Docker Desktop is installed, explore the official Docker documentation and tutorials to learn the basics of Docker, including creating Docker files, building and running containers, and deploying applications to a Docker Swarm or Kubernetes cluster. Experiment with different Docker commands and features, such as networking, volumes, and Docker Compose, to gain a deeper understanding of how Docker works and how it can benefit your development workflow. Join the vibrant Docker community to connect with other developers, share best practices, and get help with troubleshooting issues. As you become more comfortable with Docker, consider exploring advanced topics such as container orchestration, continuous integration and deployment, and Docker security best practices to further enhance your skills and knowledge. Section 5. Best practices and tips for using Docker. When using Docker in production environments, It's essential to follow best practices and adopt proper methodologies to ensure the reliability, security, and performance of your applications. Some best practices for using Docker include keeping Docker images lightweight by minimizing the number of layers and dependencies, using multi-stage builds to optimize the size of your Docker images and improve build times, implementing a robust CI/CD pipeline to automate the build, test, and deployment process of your Dockerized applications, monitoring the health and performance of your Docker containers and clusters, using tools like Prometheus and Grafana, implementing security best practices such as image scanning, least privilege, and network segmentation to protect your Dockerized applications from security threats. By following these best practices and tips, you can leverage Docker to its full potential and maximize the benefits of containerization for your organization. Section 6. Conclusion. In conclusion, Docker has revolutionized the way we build, ship, and run applications, empowering developers and organizations to innovate faster, improve productivity, and deliver better software. By adopting Docker and containerization, you can streamline your development workflow, increase scalability and reliability, and accelerate time to market for your applications. Whether you're a developer, sysadmin, or IT manager, Docker has something to offer for everyone. Start containerizing your applications today and unlock the full potential of Docker for your organization's success. With Docker, the possibilities are endless, and the future of software development is brighter than ever before.